Hello everybody. Once again, I'm PS Strategy with my part 2 of step-by-step design and analysis of steel truss by G.A.M. Here I'm going to discuss about the calculation of wind load on the structure. Before starting the lecture, I'm requesting to all of you, please like, share and subscribe my channel. For this part, we record one book, that is IS-875-Part-3. Now, some terminology. Basic wind speed is equal to Vv. Design wind speed Vz is equal to K1, K2, K1 into K2 into K3 into K4 into Vv. This Vv. K1 is risk coefficient or probability factor. K2 height, terrain and structure size factor. K3 topography factor. K4 importance factor. This is our basic wind speed table. Our zone is Kolkata. This is city or town and basic wind speed 50 meter per second. These are the continuation of the table. Now K1 factor. K1 factor based on class of structure, mean probable design life and structure in year, basic wind speed. Our building belongs to all general building and structure category. Mean probable lifespan is 50 years. Basic wind speed in Kolkata 50. So our K1 is 1. Now K2 factor. K2 factor depends on the height of the structure, nature of the terrain and structure size factor. Definition of building category. Category 1. Surrounding of the proposed structure have no such big obstacle, just like coastal area. Category 2. Surrounding of the proposed structure have obstacle height generally between 1.5 meter to 10 meter. Example, open area near coastal area, airfield, open parkland, underdeveloped area, etc. Category 3. Surrounding of the proposed structure have number of obstacle height generally 10 meter along with few tall structure. Well wooded area, town, fully or partly developed industrial area. The example. Category 4. Surrounding of the proposed structure have number of closely spaced obstacle of height 25 meter or more. Example, large city center, well-developed industrial area, etc. Definition of Truss A, B and C building. Truss A. Structure and of their components such as cladding, glazing, roofing, etc. having maximum dimension, greatest horizontal or vertical dimension less than or equal to 20 meters. Class B. Structure and their components such as cladding, glazing, roofing, etc. having maximum dimension, greatest horizontal or vertical dimension between 20 meter and 50 meters. Class C. Structure and their components such as cladding, glazing, roofing, etc. having maximum dimension, greatest horizontal, vertical dimension greater than 50 meters. This is a chart for K2 value. The value of K2 depends on number of height, terrain category, and terrain category further classified into 4 categories. 1, 2, 3, 4. Each terrain category further divided into three classes A, B and C. A, B and C. Topography factor K3. The topography factor K3 is equal to 1 when the slope of the topography is less than 3 degree. That is for plain area. Topography factor K3 is equal to 1.36 if the slope of the topography is greater than 3 degree. For hilly area it is applicable. Importance factor for cyclonic region K4. Structure of post-cyclonic importance for emergency services such as cyclone shelter, hospital, school, communication tower, etc. The value of K4 is equal to 1.3. For industrial structure, K4 is equal to 1.15. All other structure, K4 is equal to 1. Our construction site is at Newtown, Kolkata. And from the table of basic wind speed, VV is equal to 50 meter per second. Number 2, our structure is a general structure and mean probable design life of the structure in air is 50 years. From the table of K1 factor, value of K1 is equal to 1. Overall dimension of the structure, length 20 meter, width 16 meter, height 6 meter. The proposed structures surrounded by heavy numbers of obstacles of height generally 10 meter along with few tall structures, so it belongs to category 3. Maximum dimension of the building is 20 meters, so the class of the building is class A. Height of the structure 6 meters, so the height is less than 10 meters. From the chart for the value of K2 is equal to 0.91. For plane land, we generally consider the slope of the topography is less than 3 degree. Topography factor K3 is equal to 1. This structure is a general structure. K4 is equal to 1. During dead load and live load calculation, we considered the plan area, that is span of truss into bay length. But in case of wind load, we have to consider the slope area, and the slope area is equal to slope length and the bay length. We consider wind angle as 0 when wind is blowing perpendicular to the ridge line, and we consider the wind angle as 90 degree when it is blowing parallel to the ridge line. For the calculation of external coefficient, this is our elevation of the truss, this is the height, and this is width. This is floor plan. This side is called side A, this side is called side B. This side is called C and this side is called D. Top view of the roof. Roof is divided into 4 segments. This side called E, this side called F, this side called G, this side called H. Dimension of the roof truss. Length 20 meter, width 16 meter, height 6 meter. Roof angle 27 degree. H by W is equal to 6 by 16, which is less than 0.5. LW, L by W is equal to 20 by 16. length by W 16. This is greater than 1 but less than 1.25. From table 5, external pressure coefficient for walls of a rectangular clad building. Building height ratio less than 0.5. Building plan ratio greater than 1 but less than equal to 1.5. Building elevation. This is building elevation. This is A, this is W. Plan A, B, C, D as I described earlier. This is table 6. Table 6 shows the values of external pressure coefficient CPE for pitched roof. In case of our building, H by W less than 0.5 and the roof angle is 27 degree. By the interpolation in between 20 degree and 30 degree roof angle, the value of CPE can be extracted. This table shows the external coefficient of pressure on roof. Here H by W 0.5, roof angle 20 degree and roof angle 30 degree. For roof angle 20 degree, when wind angle is 0 degree, CPE on EF side is equal to minus 0.4. GH side also minus 0.4. But for 30 degree on EF it is 0 and GH minus 0.4. No change in GH side. When wind angle is 90 degree, for 20 degree it is minus 0.7. Also for 30 degree minus 0.7. And for FH minus 0.6, minus 0.6, no change. When wind angle is 90 degree, no change in CPE. In between roof angle 20 to 30. But for wind angle 0 degree, CPE in between roof angle 20 to 30 varies from minus 0.4 to 0 on side EF. For increment of 10 degree in roof slope, change in CPE is equal to 0 minus 0.4 divided by 10 is equal to 0.04. Change in angle is 27 minus 20 is equal to 7 degree. So change in CPE is equal to 0.04 into 7 is equal to 0.28. For 27 degree roof slope, CPE on side EF is equal to minus 0.4 plus 0.28 is equal to minus 1.2. And this is the table. Total H by W 0.5, roof angle 27 degree, wind angle 0. On EF side, CPE is equal to minus 0.2, on GS side minus 0.4, on EG side minus 0.7, FH side minus 0.6. This is not required at all. But here CPE maximum when the wind angle is 90 degree and wind pressure is directly proportional to the CPE. In this case, CPE for design purpose is minus 0.7. Now I am switching over to Excel for further wind load calculation. This is our load calculation spreadsheet. The span of the truss 16 meter, rise in ratio 0.25, bay length 4 meter, total number of joint 9, rise height in meter 4 meter, equivalent number of joints 9 minus 1 that is 8, slope length 8.944. This portion of the Excel sheet shows the wind load calculation. Height of the truss is 6 meters. Length of the truss is 20 meters. Width of the truss 16 meters. Roof angle 27 degrees. Basic wind speed in Kolkata 50. It is all general building. Not 5 years, not 25 years. All general building and lifespan 50 years. Calcutta is not coastal area, so well-wooded area, town full or fully or partly developed industrial area. Maximum horizontal distance is 20 meters. Slope angle less than. This is not cyclonic region, non-cyclonic region. Opening 5%. We have external pressure coefficient on roof CPE when wind is blowing from 0-degree angle. On EF zone minus 0.12, on GH zone minus 0.4. When wind angle is 90-degree, pressure coefficient CPE on EG minus 0.7, on FH minus 0.6. Design wind speed is equal to basic wind speed into K1, K2, K3 is equal to 45.5 meter per second. Design wind speed Vz is equal to Vv into K1 into K2 into K3 into K4 is equal to 45.5 meter per second. Design wind pressure is equal to 0.6 into Vz square is equal to 1243 Newton per meter square. Net pressure on roof CPE minus positive CPI. This value minus 3 point on EF minus 3.9 minus 398 Newton per meter square, GH minus 746 Newton per meter square, EG minus 1119 Newton per meter square, FH minus 995. Here external pressure minus and minus negative internal pressure coefficient. On EF zone 100 Newton per meter square. In this manner, the design wind load. These two are the design wind load for internal and external joint of the truss. Our design wind load on joints when the wind angle is 90-degree and side EG. Internal joints, it is minus 10,010 Newton. On external joint, it is minus 5,004, half of the internal joints. Negative pressure indicates that it is away from the roof and it is uplift pressure. If you are interested to develop your own load calculation Excel spreadsheet, then I can make a separate video on it. Thank you for watching. I'm waiting for your likes here and comment. If you think this presentation is useful to you, please contribute. Your contribution will inspire me and it will help me to decorate my future presentation with colorful manner. Thank you.